Conversion from Moore to Mealy machine. Suppose we have this Moore machine, Q0 with 00 output, Q0 to Q0 B transition, Q0 to Q1 A transition, and Q1 with 10 output, and on Q1 there is a transition of A, and Q1 to Q2 there is a transition for B, and Q2 with 110 output, Q2 to Q2 transition of A, and Q2 to Q1 transition of B. Suppose we have this Moore machine, so we need to convert this into Mealy machine. So what we do initially, we start with the initial state Q0, and we make a transition of B, or we make a self loop of B on Q0 with 00 output. Now we make another state Q1 with A transition from Q0 to Q1 with A transition with 10 output. Why 10 output? Because we can clearly see that on Q1 what output we have? 10. So we make a transition from Q0 to Q1 A with 10 output. And in the similar way we make, because here is a loop of A on Q1 state in Moore machine, so we make a loop of A on Q1 in Mealy machine also with 10 output, because at Q1 what output we have? 10 with 10 output. Now we make a transition from Q1 to Q2 B. We make a transition from Q1 to Q2 B with 110 output, with 110 output, with 110 output. Why? Because at Q0 in Moore machine what output we have? 110. So from Q1 to Q2 we make a transition of B with 110 output, and on Q2 there is a loop of A on Moore machine, so we also make a loop of A on Mealy machine with 110 output, because on Q2 what output we have? 110. Now we are moving from Q2 to Q1 with V transition, but at Q1 what output we have? 10. So we make a transition of B with 10 output. So in that way we can convert from Moore to Mealy machine. Now we see the transition table of Moore and Mealy machine. Transition table of Moore and Mealy machine. A, B transition, A transition with state Q0. Q0 to A in Moore machine, where we are moving on Q1. So we write here Q1. Q0 to B, where we are moving on Q0 in Moore machine. So we write here Q0. And what output we have on Q0? We have 00 output. So we write here 00. Now on Q1 to A, where we are moving on Q1 only. So we write here Q1. Q1 to B, where we are moving Q1 to B, we are moving on Q2. So we write here Q2. What is the output on Q1 in Moore machine? We have 10. So we write here 10. Now Q2 state. Q2 to A, where we are moving on Q2 only. So we write here Q2. Q2 to B, where we are moving on Q1. So we write here Q1. And what output we have in Q2 in Moore machine? 110. So we write here 110. This is the transition table for Moore machine. And for Mealy machine, A transition for B transition. For states, Q0 state. For Q0 state, for A, for Q0 state, for transition A, from Q0 state, where we are moving to Q1. Q1 with what output? 10 output. But what output? 10 output. And from Q1 to B, where we are moving on Q0 state only, with what output? 00 output. So we write Q0 0 0. Now move to the next state Q1. From Q1 to A, where we are moving on Q1 only, with what output? 1 0 output. So we write here Q1 1 0. And from Q1 to B, where we are moving on Q2, with what output? 1 1 0. And from Q2 to A, where we are moving on Q2 only, with what output? 1 1 0. And from Q1 to B, where we are moving on Q1, with what output? 1 0. So this is a transition table for Mealy machine, and this is a transition table for Moore machine. So in that way we can convert Moore to Mealy machine. And regarding this, one more thing is M states and N output. If we have M states and N output in Moore machine, then it will be equivalent to Mealy machine. It will be equivalent to Mealy machine with less than equals to M states. Less than equals to M states. So here we can clearly see that how many states we have in Moore machine? We have 3 states. How many states we have? 3 states. And how many output we have? 3 output. How many output we have? 3 output. So, and in Mealy machine, how many states we have? 3. How many states we have? 3. So we can clearly see that the number of states in Moore machine we have 3, and the number of states in Mealy machine we have 3, which is always less than or equals to M. So it is equals to M of Moore machine. So it verify our this condition or this thing through which we can identify that we are going in the right direction or not. In the similar way, if we do conversion from Mealy to Moore, then what we have? We have M state and N output in Mealy machine, which will be equivalent to Moore with less than is equals to Mn states or less than is equals to Mn plus 1 states. Why? Because Moore machine always have one extra output. Because Moore machine always have one extra output. As we know, if we want to cross check any string, then whatever output we have in the initial state, first we have to put that output in that string, then we go further. So that's why one extra output. That's why one extra state. So now cross check for this also. As we made the Mealy machine for OR function in our last lecture, so from this we start. As we know what we have in OR, whenever we have one single output, that will be true. So for 0 0 it will be 0, for 0 1 it will be 1, for 1 0 it will be 1, and for 1 1 it will be 1. Whenever one output is true, the value will be true according to OR gate, as we have discussed earlier in our last lecture. So this is the Mealy machine. This is the Mealy machine, and we are converting it to the Moore machine. And one more important thing is, before going to further, one more important thing about this conversion, that when more than two output of same state come, when we have more than two output of same state, then there is a need to convert, there is a need to convert that one state into two state. When more than two output of same state, then there is a need to convert that one state into two state. Now we see from here, this is the Mealy machine for OR function. We are converting into the Moore machine. So we start with the Q0 with 0 output. Start with the Q0 with 0 output, because what output we have? Either 0 or 1. So we start with the 0 output Q0, and for 0 0, because what output we have? For 0 0 we have 0 output, and we move to the next state Q1 with 1 output. So if we have 0 1, so we have 1 output. If we have 1 0, then we have 1 output, and if we have 1 1, then we have 1 output. Q0 with 0 output and Q1 with 1 output. So from here, if we have 0 0, then we are on the Q0, and if we have 0 1 1 0 or 1 1, then we are moving to Q1. For 0 1, 1 output, for 1 1, 1 output, and for 1 0, 1 output. So this is the Moore machine from Mealy to Moore conversion. So M states, how many states we have in Mealy machine? From this is for Moore to Mealy, and this is for Mealy to Moore. So from here, how many states we have? 1. And the output, what we have? Two kinds of output, 0 or 1. Number of states 1 and output 2 in Mealy machine. So how many states can be less than or equals to mn? So if we multiply both, then what we get? 2. So which is less than or equals to mn? Which is less than or equals to mn, because m is 1 and n is 2 here. So this is satisfy the condition. So this is true. So as we write here, when more than two output of same state, when more than two output of same state come, then there is a need to convert one state into two states. That's why we convert that one state into two state in Moore machine. When more than two output of same state, then there is a need to convert from one state to another states. So this is the conversion from Mealy to Moore machine, and the condition is satisfied here, where m states and n output with Mealy machine will be equals to Moore machine with less than mn states, or less than mn plus 1 state. So it is equivalent to mn state, because m is 1 here, n is 2 here. So this is 2. So this is verify the condition.